Hi, my name is Vincent, and today I want to take a look at differentiating using the definition of the derivative. So we have the problem, use the definition of the derivative to differentiate f of x equals x squared plus 3x. So we start off, we could write the function f of x equals x squared plus 3x. And now our goal is to find the derivative of this function using the definition of the derivative. So we need to recall that the definition of the derivative, f prime of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So the trick with this problem, the tough part is just setting it up correctly. So we really need to focus in on this part here, f of x plus h. So we need to be able to evaluate this function at x plus h. So for the next line, let's say for line 2, we have f prime of x is equal to the limit as h approaches 0. And now instead of f of x plus h, now we're going to substitute x plus h into the function wherever we see an x. So we have x squared, but we're replacing x with x plus h. So we have x plus h squared. And now plus 3 times x, but we're evaluating this for x plus h. So we have 3 times x plus h. And now we're subtracting f of x. But remember, f of x is equal to x squared plus 3x. So we're subtracting x squared plus 3x. And remember, this is still all over h. So this is the part here we really need to be careful of. This segment here represents f of x plus h. All we do is replace all the x's with x plus h. So now for the next line, we could evaluate this and simplify it a little bit more. We have, for line 3, we're looking at f prime of x is equal to, and now we have the limit as h approaches 0. And now I'm not going to do all of the steps in multiplying two binomials together, but x plus h squared, or x plus h times x plus h, is equal to, we have x squared plus 2xh plus h squared. And now for the next piece, this is how we just evaluate x plus h squared. But now we need to distribute 3 times x plus h. When we distribute, we have 3 times x is 3x, and 3 times h is a positive 3h. So now the last thing we need to do is distribute this negative. So we have a negative x squared. And now you can think of this as a negative 1, but negative 1 times 3x is a negative 3x. And this is still all over h. So now the next thing we want to do is, before we move forward, let's identify like terms that can cancel out. Notice how we have a positive x squared and we have a negative x squared. We also have a positive 3x and a negative 3x. So these like terms, since they're inverses of each other, x squared minus x squared will cancel, and 3x minus 3x will cancel. This part is really critical, because with using the definition of the derivative, we want some terms to cancel out so that we can move to the next step of factoring. So let's just rewrite this expression here without the terms that just canceled out. So we have f prime of x is equal to, and now we have the limit as h approaches 0, and all that's left is 2xh plus h squared plus 3h all over h. So now what we need to do for the next line is factor out a common h from each term in the numerator. So we have, for line 5, we're looking at f prime of x equals the limit as h approaches 0, and now we're going to factor out a common h. So we have, when we factor out h from 2xh, we're left with 2x. When we factor in h away from h squared, we're left with h. And finally, when we factor h away from 3h, we're left with a positive 3. And this is all over h. But what this just accomplished Now h divided by h will cancel. So for line 6, we're looking at f prime of x is equal to the limit as h approaches 0, and all we have now is 2x plus h plus 3. So now this is a basic limit, so we could write our answer. We have f prime of x equals, so we have f prime of x equals, and now the limit as h approaches 0 of 2x, 2x is unaffected by the limit as h approaches 0. So we could just rewrite this term as 2x. But now the limit as h approaches 0 of h, well, this would shrink this h term to 0. So in some sense we could think of this h as being crossed off. And now the limit as h approaches 0 of positive 3 is just positive 3. So from line 6 to line 7, the two terms that survived the limit as h approaches 0 were 2x plus 3. So it follows that the derivative of the function x squared plus 3x, we could call this f prime of x, is equal to 2x plus 3. Now finding the derivative of this function is a lot easier when you use the power rule or other techniques of differentiation, but it's important to be able to use the definition of the derivative, because questions like this will pop up on standardized tests, but it is important to have a general view of the derivative, not just a computational way of getting there, but using the definition of the derivative. Okay, well, this is going to conclude this video on differentiating with the definition of the derivative. Thank you all for watching, and I hope that this was helpful.